is lesson 3.3a. We are going to talk about solving quadratics by factoring. So this is our next method. We talked about square rooting. Our next method is to solve by factoring. Our goal with this is to be able to solve quadratics by factoring when a is equal to 1, and we'll talk about what that means. We also want to know when this method is appropriate to use. So square rooting is always appropriate to use when you have no middle term. When we're talking about quadratic functions that have an x term, or in this case an m term, but a middle term, square rooting is not an option. So factoring is your next best option. Hopefully it becomes easy for you. It takes a little bit of practice, I will tell you that. So make sure that you are practicing your factoring. But at some point, it will get easy, it'll make sense, and then this is definitely your second method that you want to use. So when we are factoring, what we are doing is we are breaking this quadratic apart into two pieces, and then this will help us solve for our 2x values, okay? What we want to do is we want to start with this m squared, and we want to break it apart and put an m in each parenthesis. Again, this gives us something linear that we can solve, which makes it a lot easier for us to figure this out. Now, what we're looking for are factors of 8 that are going to add or subtract to make 6. So let's start by listing out all the factors of 8. First, there's 1 and 8, 2 and 4, and that's it. There's nothing else that multiplies to be 8. So one of these two pairs is going to work to make 6. Well, I look at this and I go, well, duh, 2 plus 4 is 6. That's pretty easy, right? So I know that I'm going to put a 2 here, and I'm going to put a 4 here. And then how do I make 6? I add them together. So I need a plus sign in each parenthesis. That is factoring. All I did was break apart the factors of 8 and position them so that they would multiply, or add, to equal 6. Now, I'm not done because I haven't solved. So what I'm going to do is I'm going to take each of these parentheses and I'm going to make it equal to 0, and I'm going to solve. So my first parenthesis is m plus 2 equals 0. I'm going to subtract 2, and I get m equals negative 2. My second parenthesis is m plus 4 equals 0. I'm going to subtract 4, and I get m equals negative 4. This is how I find the two different solutions of my quadratic. If I put either of these two numbers back into this quadratic equation, I will get an answer of 0. If I take negative 2 squared plus 6 times negative 2 plus 8, I will get 0. And if I do the same thing with negative 4, I will also get 0. These are my two solutions, okay? Remember we talked about a quadratic always has two solutions? When we're square rooting, the two solutions are easy because it's just plus or minus whatever, plus or minus 4, plus or minus square root of 7. But not every quadratic has just a square root like that. A lot of times your quadratic will have two different answers that you have to solve for by factoring, okay? Let's look at another one here. We've got g squared minus 4g minus 12 equals 0. So I'm going to start with my two sets of parentheses. I'm going to break the g squared apart into g and g. Now I need to know what factors of 12 are going to subtract. Notice this time they are subtracting to be negative 4. That sign in front of your constant, your third number, always tells you what you're doing, what operation you're doing to get the middle number, either adding or subtracting, okay? So I need to know factors of 12. What are my options? 1 and 12, 2 and 6, 3 and 4. Well, 1 and 12 is not going to get me 4. 3 and 4 is not going to get me 4, but 2 and 6 will, right? Because 6 minus 2 is 4. However, I need a negative 4. So instead of 6 minus 2, I need to have a positive 2 minus 6. That's what gives me the negative 4. So pay really close attention to your signs. Make sure you get them in the right spot so that you get the correct middle term, okay? We can't have 6 minus 2 because that gives us a positive 4, which is not our equation. When I solve, I want to get the correct solutions that when I plug them in will give me 0. Now I'm going to solve each of these again. I'm going to say g plus 2 equals 0, subtract 2, and g equals negative 2. Same thing over here, g minus 6 equals 0, add 6, and I get g equals 6. I hope you are starting to see a little bit of a pattern with what's in the parentheses and how we get our answer. but I'm going to hold off on that for a minute. Let's factor this next one. We're going to break this down into our two parentheses. F squared breaks down into F and F. Now, what factors of 9 are going to add to give me 6? Well, my factors of 9 are 1 and 9 or 3 and 3. Obviously, 3 plus 3 is 6, right? That one's kind of a no-brainer. So I'm going to do 3 and 3, and then I know that I'm adding them together to make a positive 6. So I want positive 3 and positive 3. Now when I solve these, f plus 3 equals 0, I'm going to subtract 3 and I get f equals negative 3. Clearly the other one, because the parentheses are the same, I'm going to get the same answer, okay? So I only have really one solution here, f equals negative 3, but this is what's called a double root. So when you're graphing this, the graph would touch the x-axis at negative 3, but would not go through it. This is a double root. Negative 3 is actually also the vertex of this quadratic, which is kind of cool. So this one's a little bit different. Even though there's only one answer, I'm air quoting that, there are actually two answers. They just happen to be the same number, okay? Are you starting to see the pattern, by the way, when we are factoring and we're looking at what's in the parentheses? You can kind of get your answer right from that without necessarily solving the equation. Now remember, when you are solving, your equation must be equal to 0 first. And I just put a little helpful hint here. Keep your squared term positive. It makes your life so much easier if that guy is positive. If you're trying to deal with a negative x squared, it gets real ugly real quick, okay? So try to keep it positive. If that means that you need to move it to the other side, then do so. Now look at this one. This one is not equal to 0, so I need to make it. So what I'm going to do is I'm going to subtract 42 to move it to the other side. Now I've got a quadratic that I can factor. So I'm going to break this apart into my two sets of parentheses. I'm going to break my x squared apart into x and x. And then I want to know what factors of 42 are going to subtract to give me negative 1. Remember that if there's no number there, it's a 1, in this case a negative 1 because I'm subtracting. So let's start with our factors of 42. 1 and 42, 2 and 21, 3 and 14, 4 doesn't go, 5 doesn't go, 6 and 7. Now looking at this, which one's going to give me a 1? Clearly 6 and 7, okay? So I know I'm subtracting them. Now, how do I subtract them to get a negative 1? Is it going to be 6 minus 7, or is it going to be 7 minus 6? Well, I know that 6 minus 7 is what gives me a negative 1. Now, hopefully you're seeing that the answers are really just the opposite of what's in the parentheses. So my answers here are negative 6 and positive 7. Did you notice that as I was solving each one, the answer that you get for the parentheses is always the opposite of what you started with? That's definitely a shortcut that you can use, okay? Make life a little easier for yourself so you don't have to set up the whole equation and solve. Once you get the parentheses, it's the opposite. So let's try another one here. This one needs to be equal to 0 too. So this time I'm going to add 8w in order to get my equation equal to 0. Now I'm going to break it apart and I'm going to be asking myself what factors of 65 are going to subtract to be positive 8. Not real familiar with my factors of 65. So I know 1 and 65, obviously. Okay, it ends in 5, so a 5 has to go into it. So I'm going to divide 65 by 5. If I put that in my calculator, I get 13. Then I think to myself, hold up, 5 and 13 makes 8. I know 13 minus 5 gives me 8. So I'm going to use that pair. And like I already said, I know that 13 minus 5 gives me the positive 8 that I need, which means that my solutions are positive 5 and negative 13. Remember, we're always taking the opposite of what's in the parentheses. Okay? So when you're factoring, first of all, make sure that it's equal to 0. Second of all, know your factors. A multiplication table is always helpful. You're welcome to look one up. But if you can figure out which pairs of factors add or subtract, look at that sign, to get that middle number, put them in the parentheses, and then take the opposite. Now, why do we do this? What are we finding when we're solving, okay? So I wanted to just show you this last one. This is the one we just factored, and we found on our last screen, I'm going to flip back a second, that w is equal to 5 and negative 13 here, or x in this case, okay? I can't graph w's on my on Desmos. But anyways, I know that x equals negative, or positive 5, sorry, and negative 13. Look at the graph. When I graphed this, what did I find? I found the x-intercepts. So the solutions of all of these equations are the points where the graph crosses the x-intercept, or in the case of that one double root that I was talking about where it touches the x-axis, okay? So the whole point of this is to be able to find the solution, or the roots, which is where the graph crosses the x-axis. Where the graph crosses the x-axis, y is 0, and that gives us a lot of information depending on what our situation is. A lot of times we talk about trajectory with quadratics. We want to know when the ball hits the ground, or when the bullet hits the target, or whatever it might be. And so a quadratic will give us that information. Sometimes we're talking about marketing uses quadratics. And so you want to know where the break-even point is. That would be at the x-intercepts, okay? So these tell us a lot of different information, and what we're finding are the x-intercepts when we're solving, okay? So I just kind of want to point that out for you so you know why we're doing this and what it relates to. As always, this has been another production of Khan Alonso Inc. I hope that you are learning math. And if you have any questions about quadratics, let us know. We are more than happy to help. Otherwise, take care.